Geothermal energy sounds cool in theory, tapping into the natural heat of the Earth to provide energy. But does it actually work? And how exactly do we harvest that power from miles below the surface? Strap in, folks, because we're about to blow your mind with the wild ways that geothermal truly functions. We all know the Earth's core is super hot, around 7,000 degrees Fahrenheit. But it's not like we can just stick a straw down a few miles and suck up lava juices, right? No. Accessing that thermal energy is way more complex than it seems. You see, between the scorching core and the surface where we live, there are all these invisible zones where heat is transferred through conduction, convection, and radiation. Now picture the Earth like an onion. It has layers. Near the surface is the crust, a thin semi-solid shell made of rocks like granite and basalt. Below that is the mantle, a thick, mostly solid layer that makes up over 80% of the Earth's volume. And way down in the center is the outer core, which is liquid, and the inner core, which is solid but almost as hot as the sun. The heat trapped underground gets absorbed by water flowing through cracks and pores in the fractured rock formations deep below the surface. Over thousands of years, this hot groundwater slowly circulates through and permeates large areas underground, forming vast geothermal reservoir systems. Temperature gradients driving the flow and convection of these reservoirs allow the Earth's remnant heat to be concentrated over wide regions existing far below the reach of normal wells. Now here's where it starts getting wild. Geothermal plants use wells drilled deep into the ground to access these underground heat pockets. But they aren't normal wells. They have to be able to withstand extreme temperatures and pressures far beyond what an oil rig deals with. Specialist drilling rigs pound steel pipes over a mile into the earth in sections. As they go deeper, the ground temperature rises dramatically, reaching over 200 degrees Fahrenheit at shallow depths and way past 300 down below. Any equipment going in needs super tough alloys that won't melt. Once a suitable hot zone is located, two types of wells are drilled: injection and production wells. The injection wells are used to pump water down under high pressure. As it heats up from contact with the hot rocks, it turns to steam. This steaming hot water is then extracted through the production wells, ready to generate power. But how exactly does it generate energy? That's where things get really wild, because instead of being piped to a normal power plant, the steam is fed directly into a turbine. As it rushes through at ultra-high pressures and temperatures, it spins giant turbine blades insanely fast, up to 3,600 revolutions per minute. The spinning shaft is then connected to a generator which converts the kinetic energy into electricity, all without any fossil fuels involved, just pure natural heat from inside the Earth's crust. Plus, because it involves using water, geothermal is considered renewable as long as reservoirs are managed properly. No fossil emissions, no fussing with wind or sun. It seems like clean green geothermal has it made, right? Well, not so fast. Setting up geothermal plants requires gigantic upfront costs for all the specialist drilling and well construction. Finding economic reservoirs of high heat is also tricky since underground conditions can vary drastically over short distances. There is also the challenge of transmitting the electricity generated from remote geothermal sites to population centers. Extensive transmission lines are needed to link geothermal power plants, which are often located in rugged mountainous or volcanic areas, to urban load centers. This additional infrastructure brings further investment requirements. There's also a risk that tap zones could be stressed and potentially trigger small quakes if excessive fluid is removed. And while steam from shallow geothermal is clean, emissions can be released if gases like hydrogen sulfide are present deep underground. Proper sealing is key to containment. Geothermal isn't quite as simple as it sounds. Tapping the immense heat of Earth's interior through highly engineered wells is no easy feat, but the payoff of zero-emission baseload power makes it worth the challenge. The next time you flip a switch, think of the fiery furnace churning away miles below your feet, powering your home without using a drop of oil. Now that's something you just won't believe until you hear how it's truly done. If you found this look into geothermal energy fascinating, don't forget to like, comment, and subscribe for more energy learning journeys.